All right, so let's look at transformations of functions. And so we've got an example B here. We've got g of x equals 1/2 times the absolute value of x plus 3 minus 2. Parent function name, we've got absolute value bars. So this is what we call the absolute value function, which you see right here. So it's a V shape, the kind of vertex of that V is at 0, 0, so we've got a V shape. And so I'm going to draw the original right here. And when I draw the original, I'm going to draw all the original as dashed. Okay, so this is the original function. It's called the absolute value function. So absolute value. Now the parent function equation, okay, the equation of the parent function is just y equals the absolute value of x. Okay, now transformation. So now we're going to see how is this different from that. Okay, we've got three differences that I see, and we're going to talk about those. First off, I want to talk about what's inside the absolute value bars, okay? That's adding 3 to x. Anything you do to the x is a horizontal move, okay? And you're adding 3 to the x. So what does adding 3 to the x do that shifts your graph to the left? So it's going to go left. It's going to shift left 3 units. Okay, now let's look at this. I'm going to write this right up here too. We also have a -2 on the outside. Anytime you have a -2, anytime you're adding or subtracting from the whole thing, it's going to be shifting it up and down. So -2 minus k be shifting down 2 units. So down 2 units. And then lastly, we've got this multiplied by 1/2. Anytime you multiply by a 1/2, it's going to be stretching or compressing your graph vertically. So now, here's how you tell the difference. Okay, and I get these mixed up. If it's a number, if this number is bigger than 1, then this is called if its number is bigger than 1, it's called it's a vertical stretch / compression, moving closer to the y-axis. If it's between 0 and 1, it compresses and it moves it to the closer to the x-axis. So this is going to be called a compression here. So a vertical compression, so it's compression because it's between 0 and 1/2. So and then you could say a vertical compression of, factor 1/2. Sometimes we say a factor 1/2. Okay, so let's talk about what all does that mean. I'm going to explain this more here in a moment. All right, so shift left. Let's do these shifts first. So left 3, down 2 puts us here. So we're going to left 3, down 2. Now, here's how vertical compression of factor 1/2 goes. If this is between 0 and 1, it makes the graph wider. If this compression is greater than 1, it makes it narrower. So what it's going to do is it's going to make this graph wider than normal. So instead of being like, I'm going to draw a little kind of dash line. Instead of being like this, like a kind of a normal one, it's going to be wider. Okay. It's going to make the graph wider. Okay. So it makes graph wider. If this was like 2, then it would make the graph narrower. Okay, and so I could show you this real quick. I have y equals, I go to math, NUM, ABS. I've got, there's my parent function right there, and I'm going to show you the difference. 1/2 math, NUM, ABS, x, x plus 3. And it's good sometimes if you can check this. Whoops, zoom. I need to go back to the normal viewing window. So zoom. To do that, I'll do zoom 6. Let me get out of there. Zoom 6. So there's your parent function. That's the first dash one. And then you see this new one is wider than the original, okay? And so there's a sketch for the transform function.